Hi there, circles. So we're going to change a bit of topic really here, aren't we? Do something a bit different. And first thing I want you to do is have a look at the circle, have a look at the bits that I've labelled, the different parts of it on there, and think about what the different names are for those different bits of the circle. Okay, and so press pause on the video. You could write them down or just keep them in your head. I'd rather you wrote them down, but you haven't got anything to write with. You'll have to do it in your head and see if you can figure out what those names are. So pause the video and unpause when you're done. Okay, so we've unpaused. Let's have a little look at what these things are then. So let's do them one at a time. Right, so there's our circle. Now the thing that's actually around the outside is called the circumference. And what we mean by the circumference is, if I put a little marker there, we mean the distance all the way around the outside. It's basically the circle. You know, how far is that circle is what we call the circumference, okay? Essentially the perimeter of the circle. Then, what about this one? Now this comes from there's the center of the circle, so it's from the center to the outside. This is a radius. This is a radius. It just goes from the center directly to the outside. And it doesn't matter where you draw the radius, it will be a straight line and it will always be exactly the same length because it's always the same distance from the center to the outside. Each one of these would be a radius. Okay. But what if we go all the way across? Well, if we go all the way across, it's called a diameter. Again, it has to go through the middle. It's not just any old line from one side to another. If you have one line that goes from one side to the other, that is called a chord. But it's called a diameter when it goes through the middle. And this is like a slice of cake. You've got your cake, you're looking down on it, you cut your slice. This is called a sector. And similar word. This one looks more like a bit of orange, doesn't it? You take a lump of orange out of it, and what is this? An orange segment, and that's exactly what this is. It's a segment. So if you've got a line from one side to the other of a circle, the area that's sort of enclosed on either side of that is called a segment. Now remember, we said that the actual line itself from one side to the other is called a chord. And last one, this one. Now, this line here is a straight line, and it just touches the edge of the circle at one point. It doesn't cross through in two places, you know, because this line crosses through in two places. It has to be where it only meets at one point, and this we call a tangent. It's a tangent to the circle. It's just a line that's just sort of just resting against the circle at one particular point. Now these are the two that people really quite often get confused, the sector and the segment. So do try and remember, sector's like a slice of cake, segment is like a slice of orange, a segment of orange when you look on the side there. And here we are, so what's this one called, remember? It's a diameter. And then of course we've got the radius as well. Now let's think about what the radius is. The radius goes from the center to the outside. So if that's my radius, well, actually, we could do a radius from the center to the outside along that part of the diameter, couldn't we? And we could do it the other side as well. So there's one radius, there's another radius, but all the way across is a diameter. So what we say here is that two radiuses is the same as one diameter. So if I know either of those, I can find the other one because one is double the other. You know, you need two radiuses to make up the diameter. Now then, what have we got here? So, there we go, there's another diameter. Right, what I'm going to think of now, I'm going to take that diameter and I'm going to lay it around the outside of my circle. And I'm going to sort of see how many times I can do that. So, there's my diameter and I've sort of curved it around the outside of my circle. Now, really, obviously it should be on the circle. I've just drawn it slightly off of the circle just so you can, you know, you can see that it's there. And then there's another one, so that's two, you know, so okay, so we've got one there, that's the second one, that's two, and let's do a third one, that's three, so I can get three diameters around the outside, but look, there's a bit of a gap here. It's a bit more than 3, isn't it? In fact, on every single circle, if you take the diameter, the measurement all the way across from one side to the other going through the centre, you can lay it round the outside of any circle just a little bit more than 3 times. And in fact, it's exactly 3.1415926535 etc. times. That's exactly how many times you can fit a diameter around the outside of your circle. Now I've put 3 little dots here because actually these decimal places go on forever and they never stop and there's no pattern to them. It's an irrational number, and you might have seen this number before. Okay, just keep in mind this is the number of times the diameter will fit around the circle. This number we use a special letter to represent it, because look, there's so many decimal places, an infinite amount of them, that it would just take too long to write them all out. So instead we just use a letter, and we use a Greek letter, and that letter is this one, and this letter is pi. Greek letter pi, which you might have heard of. It's spelt slightly differently to the sort of cherry pie that you eat, because there's no E on the end, it's just pi. And that letter there just represents this number. Just something that's just a little bit more than 3. All right? So that's exactly what pi is. It is just the number of times that you could fit a diameter around a circle. And what I want you to do is, because this is quite a short lesson today, but you're going to go off and do some work on your own, I want you to investigate that. Okay, what you do is find some circles around the room or around your house or wherever, or outside or wherever you can find some circles. Okay, and there's a couple of ideas. You could maybe the end of a glue stick or something like that, or a sellotape roll, or a sweet tin like a Heroes tin, or Quality Street or something like that, or a Pringles tube, or a bike wheel, or maybe a saucepan, or a bottle, anything that is circular. Okay, and I want you to draw out this table. Now I will include a PDF of this table, so if you do have a printer at home you can print it, but I'm not expecting you to. You can just get your ruler, get your pencil or pen, and just draw out a table just with these columns. So the object, so you're going to write down what the name of the object is, and then you've got 3 other columns there: diameter, circumference, and the thing I'll come to in a sec. Because this is what I want you to do. I want you to measure the diameter. So if you've got an object, let's say I've done a bottle, and I might say let's measure the diameter. I'm just looking at a bottle from here. And the diameter might be, say, 9.8 centimeters. And I would go to the nearest millimeter, so so go not just the whole centimeters, but in this case 9.8. Yeah, and then you're going to measure the distance around the outside. So you need to get. I've got a video in a minute. I'll explain what I mean by that. But measure the distance around the outside. Oh, sorry, I was just grabbing my calculator. Just hold on. And measure that circumference, and then write it down. So let's say my bottle is 30.9 centimeters. Okay, then the next thing you're going to do is divide the circumference by the diameter. So there we go. Just take that circumference measurements you've got and divide it by the diameter. So I would do, with my example, 30.9 divided by 9.8, and then write down just maybe the first couple of decimal places here. So 3.15. And write that down in the circumference divided by diameter bit. Oh, my screen's gone mad. No, I don't want that. Okay, write the answer in the table, just like I said. Yeah, okay, so you can do that for each object that you can find, as many as you can do. Then I want you to have a little think. Are they all about 3.14? So are they all roughly the same as pi? Well, 3.15 is pretty close, actually, to 3.14, isn't it? So that's what I want you to do. I want to see if they are the same. Now there's a video just coming up now that will explain how you might be able to measure it. You shouldn't need much specialist equipment. Okay? Right, okay, so this is my little instruction video of how to do the measuring part. Now you've already got the instructions of what you're measuring, but let's have a little look at what I sort of mean. So here I've got my round thing. Here's my circle at the bottom. What is it? An old Celebrations tub. Now, measuring the diameter is really easy because I've got a ruler here and it's just a straight line. I just got to make sure that I've gone to the widest point and maybe do it to the nearest millimetre. So that's 21.2 centimetres or 212 millimetres, whichever you want to use. Probably centimetres with 21.2 maybe. That's nice and easy. But what about the curved bit? What about the circumference around the outside? Now, my ruler isn't going to bend around there. Maybe you've got a bendy ruler. In that case, it's really easy because you just need to bend it. If it doesn't stretch all the way, just mark where you've got to, and then mark, measure the next bit, until you've gone all the way round, and then add it together to get the whole circumference. Now, it's a whole lot easier if you're lucky enough to have one of these. It's like a dressmaker's sort of tape measure thing. The only thing is make sure you're using the centimetre side, not the inches side, okay? Because then you can obviously, that's nice and easy because you could just wrap it all the way round and you could see whatever your circumference is, which is, what's my circumference? 67.4, I think, 67.4 centimetres. Or another alternative, maybe you've got one of these tape measures lying around because they're nice and flexible. Maybe a bit trickier, and you have to be a bit careful because it's a bit sharp. But you might be able to wrap that all the way around the outside. Or even, cool, I found this one I was looking around as well. Here's another big fabric tape measure. Okay, but if you haven't got any of those, you can improvise. Because if you could find a bit of string or something you could use a string, some old ribbon or something like that, what you could do is wrap that all the way around the outside and mark where it gets to. So there's my mark. Then you can lay it out flat and you could put a ruler on that and you could measure how long that is. I think we're looking at that, 67.4 I think. So right, that's another way you could do it. So there's all sorts of ways that you could have a go, and just do your best. Now it's likely that your measurements, when you do your division, so what did I say I had? My circumference was 67.4, wasn't it? And I'm going to divide it by my diameter that I said was 21.2, and it should be around about 3.1792, which is pretty close to pi, isn't it? That's pretty close to 3.14, and that's what you should be finding. Now, if you find that you've got something really different, like 15, then you've probably measured it wrong, or maybe you've not measured all the way across. Maybe you've not measured the diameter. Maybe you've only measured the radius from the centre or something. Okay? But anyway, just have a bit of fun. Be experimental, see what you can do. Find the circles around your house. And they have to be circles. Ovals will not do. They've got to be circular. All right? Okay, so there are some ideas of how you might go about actually measuring. Okay? So there's your task I want you to do. I want you to take a photo of your work, or if it's already typed up online, I want you to, sort of screenshot it or whatever and get that to me so I can have a look, so I can just check how many you've done. Give yourself a good 20 minutes or so to have that task, and off you pop, and then we'll have a look at circumference. Hi there, we're going to have a look at some circles again. And but first of all, before we start that, we're going to just try a really useful skill which is going to be needed today. So you will need your calculator, definitely, and you need to practice using the pi button on it. Now, if you've got one of these are the sort of ones we sell at school. It's the new Casio one, which is really, really good. Your pi button is at the bottom. The slightly older version that they used to sell is really similar as well. Now, you can't really see it there, so I've enlarged it a little bit, but look, there's a little hidden pi button just above the times 10 to the x. Now, what that means is you need to press shift to get that one. The shift button is that one there, and if you press that and then press this button, you will get pi on your calculator. Now, if your calculator does not do pi, then you could always use 3.14 as an estimation, but you really need to get yourselves one of these if you haven't. There are also all sorts of online calculators that you could use today. If you need it, just type in Desmos, so Let's just write that up there. If you need it, Desmos is a great website that's got a scientific calculator on there that you could use as well. Anyway, what I want you to do, I want you to pause the video. I want you to just work out these calculations. You know, what's 3 times pi, what's 8 times pi, and so on, or pi times pi, and answer them to 3 decimal places, and then unpause the video when you're done and see if you've got them right. Off you go. Okay, we've unpaused. Now, the first thing you might have struggled with, possibly, is the SD button. Now, if you've got this calculator and you type in 3 times pi, what it puts on your calculator is 3 pi, which is really useful at times, but not for what we want, because we want it decimal places. So if you can see that there, you need to press, I'm just trying to highlight it in blue on the background, but that SD button that I'm just hovering around here, SD changes it into decimals. And if you press that, for example, you would get here 9.42, and to 3 decimal places, it's 5, right? 9.425. And then if you're doing 8 times pi, press SD, and you get 25.133 to 3 decimal places, because I did say that. Look, there we go. And then 10 times by pi, you get 10 pi, press SD, and you get 31.4, that's a point, 416 to 3 decimal places. And then 12 times by the pi, by pi, is 37.699 to 3 decimal places. And lastly, pi times by itself, so this is pi squared, is 9.8, and it's 70, because the next number, this would have been a 9, and if you look at your display, you'll see what I mean, but it rounds up to 870, because you need to round up the last one, and it turns into that. Okay, well, anyway, good practice for using pi. Let's move on. Now, what we're going to do today is the circumference of a circle. Now, the circumference of a circle is the distance around the outside. The circumference is the outside, and we want to know how long it is to go from all the way around. You know, it's a bit like wrapping a bit of ribbon around a Pringles tube. How much ribbon do I need? And we spoke last time about the diameter, which is all the way across. This is our diameter. And I can wrap that around the outside of my circle just over 3 times. And we gave a number to the amount of times that you can fit it, because it's just over 3, and it's this, 3.1415, etc. And do you remember, we called it pi? It's actually just our main man-made number, because it's got an infinite amount of decimal places, and it's such a useful number that we give it this letter to represent how many times the diameter will go around the outside. Now, this is really useful, because actually if I want to know the distance around the outside, all I need to do is measure the distance across the middle, and then times it by 3.14, because I know that's how many times it fits around the outside. So if I do the diameter times by pi, I get the circumference. Okay, so circumference is just pi times diameter. And I've got a really good song about that, which I'm not going to sing now because I haven't got time, but I'll do it another time. Circumference is pi times diameter. So that's where this little formula comes from. Now, the thing is, you've got to make sure that the measurement you've got is the diameter. If you have, then it's that straightforward. If you haven't, then it's not. So I always do have a bit of a habit of writing this. If I'm doing a circle question, I put R equals, I put D equals, and I want to write down what the radius and diameter is. Even if I don't need the radius, I just like writing it down, so I've got both and I can choose which one I want. Now look at this. Is this a radius or a diameter? Well, it's a diameter. So the diameter in this case is 12 centimeters. Remember, the radius goes from the center to the outside, so it's going to be half of that, which is 6. Right, now circumference is pi times diameter. It says so. So I need to do pi times by 12. After all that. Oh, we did this calculation a minute ago, didn't we? And pi times by 12 is, and I'm going to round it to 1 decimal place, right? I reckon we'll do the rest of today to 1 decimal place. 37.7 centimeters, and that was rounded to 1 dp. Yep, so that's it. Just pi times diameter. Right, let's try another couple. Oh, because that. Oh, I had a little animation to show you all the way around. So the distance all the way around the circle is 37.7 centimeters to 1 decimal place. What about this one? Well, first of all, let's write down r equals d equals. Have I got a radius or a diameter here? Well, this is a diameter, it goes all the way across, which means my radius will be half of that because the radius only goes half the way across, from the center to the outside. And so circumference is pi times diameter, so it's pi times 8. In this case, just put it in your calculator. You can't work it out yourself. Just put it in a calculator. 8 times pi is 20 to 1 decimal place again, 25.1 centimeters. Yep. Easy, huh? Here's another one, another circle. Let's put r equals, let's put d equals. Right, is this a radius or a diameter? Well, this is a radius, so I'm going to write it there. What about my diameter, though? How much would the diameter be all the way across? Well, that's going to be double the radius. It's going to be 4 centimeters. So the circumference will be pi times by 4, not times by 2. Common mistake just to multiply pi by whatever number they give you. But they're sneaky people, question people. They will do it to catch you out. Right, to 1 decimal place, 12.6 centimeters. Okay, easy, huh? Right, now my tip is to write down radius equals diameter equals, work it out. You know, then decide which one you need, times it by pi. Right, I want you to round these. Yeah, let's change it up a little bit. Let's do 2 decimal places. Why not? Okay, so press pause on the video, do all 4 of those, please, and then unpause when you're done. Okay, we've unpaused. Let's do this. Right, r equals d equals. Well, this is a radius, so the radius is 3. The diameter is all the way across, so will be 6. So circumference is pi times diameter, so it's pi times by 6. I'm going to get my calculator out. 6 times by pi to 2 decimal places will be 18.85, because it needs to round up, centimeters. Yep, that's the distance around the outside. B. Oops, F. I don't want F. What's F come from? R equals and D equals. This is a diameter because it goes all the way across. So in that case, what would the radius be? It would be half of that, which is 3.5 centimeters. Now, I need diameter, so it's pi times by 7. Right, 7 pi is to 2 decimal places, 21.99, because that's what it rounds to, centimeters. Yep. Next one, r equals, d equals. Well, this is a radius because it only goes from the center to the outside. It's only half the way across. So that's my radius, which means my diameter must be double that. So it's 13 centimeters. Now circumference equals pi times by my diameter of 13. So pi times by 13 equals to 2 decimal places 40.84 centimeters is the distance around this circle, the circumference. And last one, r equals, d equals. This is a diameter. So the radius will be half of that, only from the center to the outside. So that will be 2.5 centimeters. And it's pi times diameter to work out the outside. So it's pi times by 5. Which is, why have I put pi equals 5? I seem to have lost the ability to write. Pi times by 5, pi times diameter. Because as we know, circumference is pi times diameter, pi times diameter, pi times diameter. Circumference is pi times diameter. And area is for a future episode, so I'm not going to spoil what that is. Right, 15.71 centimeters to 2 decimal places. Yep, got the idea? Great, you're doing brilliantly. In which case, 3 more for you to do. 2 decimal places, pause the video, whack through those, round them to 2 decimal places, unpause when you're done. Go. We've unpaused because you've already finished, because you're doing really well. R equals D equals. Right, what have I got? I've got a diameter, so that's 3. My radius will be half of that, because it only goes half the way across, 1.5. Circumference then is pi times diameter, so pi times 3, which is, he says, getting his trusty calculator out, 9.42 to 2 decimal places. Give myself a little tick. Right, R equals D equals. Right, this is a radius. It only goes half the way across, which means my diameter must be double that. Right, circumference, distance around the outside, is pi times by diameter. So it's pi times by 2, which is 6.28 to 2 decimal places. Give myself a little tick. R equals D equals. Now this is a diameter, so my diameter is 4.5. My radius will be half that, so it's 2.25 centimeters. But I want the circumference, which is pi times by diameter, so pi times by 4.5. Press SD to get my decimal, which is 14.14 to 2 decimal places. Another little tick, and I might even do a little smiley face. Yeah, great stuff. Okay, right, now it's your turn to really crack down and show me what you can do. So I want you to log into Dr. Frost. If you have a problem with that, obviously I'll be around online, so, you know, mail me and we'll get you sorted. There's a task for you to do now. It's not like homework normally where you can do it any time for the next week. You've got to do it now. And it's called Circumference of a Circle, and I want you to look at each one and work out the circumference of the circle. So be careful. Remember, each time check whether you've got either the radius or the diameter, you know, because if you've got the radius of, I don't know, say 5, you'll need to double that to get the diameter, because each time you need to be doing pi times by the diameter, not just whatever number they give you, but whatever the diameter of the circle is. And it also wants you to round it to 1 decimal place as well. So if you're getting it wrong, it might be your rounding that's going wrong. Now, if you struggle with this, I want you, to write down a couple of answers, you know, with the working out, and it must be with working out. Take a quick photo and then send it to me. And say I'll be online during your lesson, and then I can tell you where you're going wrong. Okay, I can sort it out for you. Obviously, if you just say that, well, I don't get it, then that's very hard to sort of help you out. So I want you, whatever, just to have a go. Even if your working out is wrong, I just want you to put some working out down, and then I can show you where you're going wrong. Okay, and tell me what questions you've done as well. All right. Okay. Otherwise, I should be keeping an eye on this to see how well you've done. Good luck, and off you go.